Welcome back, dear students, to the tetrahedron chemistry classes. In today's class, I am going to solve another very important problem based on the salt analysis or the mixture analysis, which is also known as the qualitative analysis. And you know, these types of the questions are very important for the Iit Jee examinations, okay, as well as for the BSc and the MSc students, right? So first of all, we'll read the question, and my advice to you, don't be afraid to see or this kind of the lengthy question, right? But if you convert this question into the possible flow chart by your own, then you can understand the problem little bit in a different manner, and then you can go for the solution. Okay, so I'll do the exactly same thing. First of all, I'll read the question, and then we'll try to convert into the flow chart, and with the help of the flow charts and the observations given in the questions, we will solve this particular problem. Okay, so what you can do, you can take out your copy and pen, and you can note the things along with me, okay, so that you can solve this question along with me and get confidence to solve such kind of the problems. Okay, so a white amorphous powder A, when heated, gives the colorless gas B, which terms line water milky. So it is quite a good indicative that your compound may contain your carbonate ion, because this the test of the carbonate is that, or you can say the carbonate, when any carbonate heated, okay, so it undergoes decomposition to give the carbon dioxide gas, which is nothing but the colorless gas, which turns the lime water milky. So clear indication is that your white amorphous powder is kind of the carbonate. It's an initial impression which is given by the question itself. Okay, so and the residue C, along with that gas B, you are also getting the C, and that precipitate is C is yellow, okay, when it is hot, but white when it is cold. So it's a very important observation which is given here, and in a little while I'll tell you what important inference we can make from this observation. Okay, the residue C dissolves in the dilute HCl, and the resulting solution gives the white precipitate on the addition of the potassium ferrocyanide. Okay, white amorphous powder A alone dissolved in the dilute HCl with the evolution of the gas, which is identical in all respect to the B. So it is quite a good indicative. You know the test of the carbonate, when you add dilute HCl to the mixture, and it gives the effervescence gas with the effervescence color gas, it is basically the carbon dioxide, and A is also doing the same thing. So two observations are there for A. First of all, it is undergoing thermal decomposition to give the gas, okay, which turns the lime water milky. And secondly, when you dissolve this white amorphous powder of A in the dilute HCl, again it is giving a gas which turns the lime water milky. So definitely it's a carbonate type of the salt. Okay, and the solution of A as obtained above, the solution which we got earlier, right, gives a white precipitate D on the addition of excess ammonium hydroxide NH₄OH on passing of H2S gas. So it quite good indication here. You can see this ammonium hydroxide and your hydrogen sulfide. That means in presence of the ammonium hydroxide, that means in the ammonical solution, when you pass the H2S gas, it is basically the precipitating reagent of the fourth group. It is the precipitating reagent of the fourth group, and you know, in the fourth group there are only four radicals: zinc, manganese, nickel, cobalt, right? So your compound A, white amorphous powder, could be anything out of these four, and which this we will conclude with the help of the color of the salt in a little while. Okay, another portion of the solution, right, gives initially white precipitate E on addition of sodium hydroxide, which dissolves in the excess of it. Okay, identify A, B, C, D, E and explain the reactions as well. So this is the complete questions, and the few conclusion you can already make from here. Actually, first of all, it is the carbonate, and it may be the carbonate of the fourth group, right? And it is a white amorphous powder. So what kind of the salts are white in nature? All these things you need to understand. So now I have converted this question into the flow chart. I'm starting from here. It is my white amorphous powder, and it is undergoing thermal decomposition, and under thermal decomposition it is producing a colorless gas B and a residue C. Okay, and then what will happen? This colorless gas turns the lime water milky, so you can identify what is B. I have already identified, but I hide this particular answer from here so that you can do the practice by your own as well, not by seeing the answers given by me. Okay, and then this residue C, yellow when hot and it is white when cold, and this residue C, when dissolved in the dilute HCl, okay, we will get the solution of that C, and that solution on adding with the potassium ferrocyanide giving the white precipitate here. When dilute HCl is added to A, okay, then colorless gas is obtained. Again, it is the carbon dioxide type of the gas, and we are getting the solution of A as well. Okay, so what is there in the solution? For this, we will add excess of ammonium hydroxide to this solution, and then pass H2S gas. This is the test of the fourth group. Then we get the white precipitate of D. So we can conclude what is D from here. Okay, and in the second part, you can see the solution of A. When you add the sodium hydroxide to it, you will get the precipitate E, and when you add more sodium hydroxide to this solution, then your white precipitate gets dissolved, then you can identify your E as well. Now I am going to solve the problem. So here a very important observation I am giving to you. We have been given the white amorphous powder. So carbonates of the zinc, calcium and magnesium, they are white amorphous powder, and along with this carbonates of the zinc, magnesium and calcium, hydroxides of aluminium, zinc and magnesium are also your white amorphous powder. I am taking my zinc carbonate from here, and along with the zinc carbonate, say I am having calcium carbonate, then I am having magnesium carbonate. So these are the possibility of the compound A. So out of these three, we can say is the compound could be anything. So what we can do, we can heat all these compounds. So I'm heating them all, and then I'm getting oxide of the zinc plus carbon dioxide, oxide of the calcium. These three are the precipitates, three molecules, right, in the different reactions. They are basically your carbon dioxide gas. Okay, it is now confirmed that your compound B is nothing but it is the carbon dioxide gas. B is carbon dioxide. Now you need to decide out of these three which one is possible. So I am telling you a very, very important observation. This zinc oxide is basically thermochromic. When it is hot, due to the electronic excitation, it appears yellow, because electrons are having the enough energy when the solution is when the compound is hot, and there occurs the electronic transitions, and due to this electronic transitions, your this so-called transition metal zinc, which is forming the oxide from here, it appears yellow. Okay, but when you cool it, right, under cold condition, it becomes white. This is the nature of the zinc oxide. While your other two, calcium oxide and magnesium oxide, regardless the physical condition, right, of temperature, they always are white. So one thing is sure, the compound A cannot be your calcium carbonate and magnesium carbonate. The compound which is C, it is yellow when hot and white when cold. So your C is this one, and A is confirmed now, your zinc carbonate. So this is your A, and this is your B, this is your C. Carbon dioxide you are having, and you are passing this carbon dioxide in the lime water. Calcium hydroxide is the lime water, and then it will convert lime water milky. And why this lime water becomes milky? Insoluble white precipitate of calcium carbonate gives the milky appearance to the solutions. And if you want to balance the reaction, if you pass your excess of CO2, that means CO2 in excess, so what will happen? Your calcium bicarbonate will form, and this is soluble, thus white color disappears. So this is the first part of the problem. Now the second part, I'm going back again. Identified A, we have identified B here, this one. So if I erase this, So this is basically your carbon dioxide. Okay. And then if I erase this, then your compound, this is your carbonate, zinc carbonate. Okay. And ZnCO3 for this one. Okay. So this is A, B, C you have identified. Now you can see here, I'm doing this thing. Your residue C, okay, it is yellow when hot, white when cold, and this residue C, when dissolved with the HCl, it forms a solution, and then you add the potassium ferrocyanide to it, you will get the white precipitate. Okay. So how we can write the reaction for this? So you were having your compound C, which is your zinc oxide. We dissolved it in the HCl. So 2 of HCl, I am writing the balance reaction for this one. So this will form the ZnCl2 and then the water molecule. Okay. And what will happen? Now this is basically the ionic compound. So this solution contains Zn2 positive ions. Zn2 positive ions. It is very important. Okay. And then what will happen with K4FeCN6? You are getting a white precipitate. So how we can get the white precipitate? So here ionization sphere changes 2 of the potassium with the zinc actually. Okay. You can write here Zn2. And then you are having FeCN6 just like this. Along with this, you are having say 2 of the positive ions which are ionized or which have ionized from the ionization sphere of the compound. So what you have done here, see potassium ions, 2K positive are here, and 2K positive will be replaced by the 2 of the zinc here. So you can write this reaction as the 2 of the zinc ions. So you are getting this one, and this is nothing but this is your white precipitate. This observation you can, if I go back here, you can see solution of C, potassium ferrocyanide, it forms a white precipitate. If I delete this, yes, C is your zinc oxide. Okay, this actually I have already done. So B is carbon dioxide, C is zinc oxide, right? A is your zinc carbonate. All these things we have done. Now what you can do, we will divide this solution, which see the solution which I got by adding this salt to the dilute HCl. This solution will divide into the 2 portion. In the first portion, I'll add the ammonium hydroxide in excess and then pass the H2S gas. This is basically the 4th group analysis, and then you will get the white precipitate D. Okay. In the second portion of the solution, we'll add the sodium hydroxide and then we'll get the white precipitate of E. Okay. Which get dissolved in the sodium hydroxide. Then we'll also try to identify the D and E. Okay. This was compound A was your zinc carbonate. You have made a solution of this. That means 2 of HCl. You have formed ZnCl2 for this along with the carbon dioxide again. This is the second part of the question. And your H2O, this was your A in the first observations, and this is your B in the second observation, right? And then we will divide this solution into the 2 different portions. So in the first portion, what we'll do, we'll add NH₄OH, zinc hydroxide, ZnOH whole twice along with ammonium chloride, 2 of NH4Cl. There is no problem in that. Okay. This solution is also initially white, right? This solution is also initially white. And then what we will do, we will add excess of ammonium hydroxide to it. Complex ion will form ZnNH3 4 times, it is tetraamine. And then I am passing H2S gas to it, zinc sulfide. Okay. Along with the 2 of ammonium ion and 2 of ammonia, just like that. And this is basically zinc sulfide, we all know. It is white precipitate. It is white PPT. And if you go back on this flow chart, then you will find all these things: ammonium hydroxide, passing H2S gas, white precipitate D, and this D you have identified as zinc sulfide. So if I delete this, yes, it is your zinc sulfide. Now in the second portion, you are adding sodium hydroxide, and then white precipitate you are having, and then excess of sodium hydroxide gets dissolved. Then what is actually the E? What we'll do, we'll add NaOH to it, sodium hydroxide. So when you add the sodium hydroxide again, what will happen? it will result in the formation of the zinc hydroxide. And this zinc hydroxide is basically, if you want to balance the reaction, then you can write here 2 of NaCl. Okay. And this is basically E, which is your white precipitate. This is E. And if you add excess of sodium hydroxide to it, so again a complex compound will form Na2ZnOH whole 4. Okay. And this is soluble and colorless. So this is how you can conclude your things. So what are the answers? A, zinc carbonate. B, carbon dioxide. C, zinc oxide. D, zinc sulfide. E, capital D. Capital D is zinc sulfide. E is zinc hydroxide. So this is how you can solve such kind of the problem. Initially, if you see the problem, if you try to read the problem, it seems very difficult one, but the very convenient way is to convert that problem into the flow chart, which I have converted here actually. And then you can go for the observations which are given here. And you should also have some idea about the colors of the salt and the many other things. But if you do the practice, if you practice a lot, then you will be able to solve such kind of the problem. Otherwise it is very very difficult to solve such problems. If I remove this, so this is your zinc hydroxide. Okay. So guys, if you understood the problem, please like the lecture. And if you are watching video for the first time, please subscribe the tetrahedron chemistry classes and do share with your friends as well. I'll keep continuing to solve such kind of the problem. So stay tuned for the further problem. So that's it for today. Thank you. Thank you very much.